Hey Mathletes, in the previous video we discussed Australian Maths Contest Year 2021 test paper for the middle primary. Let's continue reviewing from question 12 to 23 in this video. So let's get started. Question number 12. I'm shuffling a deck of cards, but I accidentally drop a card on the ground every now and then. After a while I notice that I have dropped 5 cards. 5 cards. From above, the 5 cards look like one of the following picture. Which picture could it be? So in such question, when the cards are dropped, when you pick from the top, you would be able to pick without disturbing other cards would be the answer that would be making perfect sense. So let's start looking into the option number A. What we see on the topmost card appears to be 6. Okay, when the 6 is picked up, we will have card 2 on top, which has also been covered by 4 and is covered by 9. So if you will pick 4, you will sure gonna disturb card number 4, or if you will pick up card number 4, you would disturb card number 9. So not our answer. Look at the option number B here. Let's start finding out which is the topmost card, and looking at the arrow of cards here, none of the cards look to be on top, right? If you pick one, it is gonna surely disturb the other, right? So it is not our answer. Let's move on to option number C. What we have here is on top 2. When it is gone, you would be able to pick card 7. However, card 7 is being covered by partly by this card 9. So 9 itself is being covered by 4. So next card that you might pick up would be 6. However, 6 itself is covered by 7, so does not look like we would be able to pick card without disturbing others. So not our answer. Option number D, the topmost card appears to be here is basically none again, because if you will pick 2, you're gonna disturb 6. So does not look like our answer. Option number E, topmost card appears to be 6. Definitely once 6 is being picked up, you would be able to pick this without disturbing others. Once 2 is being picked up, you would be able to pick this. When it is being picked up, you can choose to pick up either 4 or 5. So option number E is the answer. Next question. Kyla had 6 apples. She cut them all into quarters and shared them equally between her 3 brothers and herself. How many apples do they each receive? So we know that there are 6 apples. Cut them all into quarters. So 1 apple will be cut into 4 quarters. If there are 6 apples, then it would be 24, right? Then remember that quarter would be called as 1/4, right? So since there are 3 brothers and herself, of course each person would get how many quarters? 6 quarters. So 6 quarters, each quarter is basically 6 multiplied by 1/4, and that would be 3/2, which will be 3/2 equivalent to 3/2, which is 1 holds 1/2. Option number E. Next question what we have here is 5 boxes are compared on a balance. Okay, so let's make a sequence again here. Question that there is being asked here is, which of the 5 boxes is the lightest? So you need to find out the lightest box. So if you look at this particular image, C appears to be light. Look at the other weights where C is being used. So C is way heavier than D, so of course D is lighter. So if you make a sequence of the lighter, so D would be coming below C. And if you look at the images involving D is heavier than E, so definitely E is lighter than D, right? E is lighter than D. Then if you look at images involving E, B is lighter than E. So what we see here is B is the lightest object. So for the question number 14, answer is B. Next question 15. Lida is saving for a cricket bat. The sports shop has the bat she wants for $56 and her grandfather has promised to pay half the price. So $56 is the amount. Half of it that would be sponsored by a grandfather would be 28. Half of 56 is 28. That you can do by dividing. So 28, right, will make 56. 28 would be given and sponsored by grandfather. Okay. And what we will left with is $28 that Lida has to pay herself. She has saved $16. How much more does she need to save before she can buy the bat? So she already has $16. So how much more? So 28 minus 16 equals, quick answer, 12. Option number B. So question number 16 here. 5 cards with digits 1, 2, 3, 4 and 9 are arranged to form the largest possible 5-digit even number. Which digit is in the tens place? So when we have to find out the largest possible digit, we start by the greatest number that we have, that is 9, 4, 3. Obviously, naturally, our answer would be 2, 1. However, we have to be careful here since the question is asking about the even number. So we need to bring 1 here and 2 would be the last digit to make an even number. So the digit that would be at tens place would be 1. Option number A. Next question. Each letter in this grid stands for a number from 1 to 6. The numbers outside the grid are the sums of the values of all the letters in each row or column. For example, in the first column, the value of M, L, L, R add to 16. And they're asking what is the value of letter L. So we would start with a row or a column which has the least unknowns. If you look at the several other like rows or columns, we would see that there are at least 3 unknowns involved. However, looking at the column number 4, we see that there is just F and 3H plus 5. So if you make an equation here, F plus 3H is equal to 5, and it's very small number. So in order to get 5 with adding like 3 times of something and the number, you need to start by with very smaller number, which would be 1. So 3 times 1 is, let's assume H is 1, so 3 times 1 is 3, so F plus 3 equals 5, F equals 2. Right? If F equals 2, we would be able to find out what would be H. That would be 1. We already assumed that. And if F and H are known, let's find out what next possible row or column. For example, let's go to the row number 4 where we have just 2 unknowns. R would be 3 times R. If you make up the equation from the row number 4 is plus H equals 13, right? We know that the H is 1, so 3R equals 12. If 3R is equal to 12, then what times 3 is 12? It's 4. So R will be 4. Now we know a value of R, we know value of F, and we know value of H as well. And the question asking is what would be the value of L? So in order to get the value of L, we must know the value of M. So let's figure out what would be the value of M. Looking at this equation, M, H, F, R, right? We know so far H, we know so far F we know so far, R as well, right? So we can easily figure out value of M. So M plus H, that is 1, plus F, which is 2, 2 plus 1 make 3, 3 plus R is 7. So M plus 7 equals 13. That is the equation building up here from column number 2. 1, M plus 7 equals 13. Thus M equals 6. When we know that the value of M is 6, we can easily apply that value here and figure out the value of L. If we apply those values, known values here, what we have, equation building up, 6 plus 2 times L plus R is 4 equals 16. So what we have here is 2 times L is equal to 6 plus 4, 10, 16 minus 10 equals 6. So L would be, what times 2 is 6? 3. So value of L will be 3. Option number C. Next question, Greg is 19 years old, Karen is 26, and Anthony is 31. In how many years from now will their ages add to 100? So let's find out what is the total of their age as of today. So 19 plus 26 plus 31. That would be 19 plus 26 would be 45. 45 plus 30 is 75 plus 76. As of today, their age, total of their age is 76. In how many years from now will their ages add 200? So we need to find out the difference in how many years total. So if we find out the difference of 100, that is in future versus today, we would know for sure in how many years. So we would have answer as 24. Now we are talking about 3 people here. It's not that one person would grow and not others. So we need to equally distribute the growth among the number of people here, which is 3. So if we distribute 3 to each person would be 8. That would be our answer, option number B. Let's move on to the next question. Mr. Nortop's class has students from Ansel. I beg your pardon if I pronounce it incorrectly. Turner, Donner, Watson, and Jackson. He made a chart showing how many live in each suburb. Unfortunately, his dog tore the bottom of the chart that we can see here, leaving only the last few letters of each suburbs. Yes, he forgot the order of the suburbs on the chart. Alright, but he remembered that more students live in Donner than Watson. So more students live in Donner than Watson. We can see that there are 2 graphs ending up with NER, NER. And definitely what they are saying is more students lived in Donner than Watson. And what we have is 2 graphs showing as ON, ON. So either of this could be Watson, but looking at the equation that the statement that they have given us here, that more students live in Donner than Watson. So definitely what looks like is this and this. This Donner, this particular graph is more than this. So definitely this could be Donner and this could be Watson, not this, because it would say that Watson would have more students than the Donner, which is not the case here. So Donner has more students than Watson. So this is the Watson, this is the Donner, and then we have just one Turner here, which is ending up with ER. So definitely this is Turner. Look at the index here, it's a 5 and 2 below is 3. So option number A would be the number of students for Turner suburb. If we move on to the next question, we have question number 20. Alexander's pen leaked on his addition homework, covering up 3 of the digits in the calculation shown. How many different possibilities are there for the correct working? So let's get right into it. What it looks like, 3. Let's put it a question mark here. Plus, let's put a question mark here again, where we don't know the numbers. 8 and 1 question mark again, and 2. So this is once you are adding 8 to some number that would give you 2. What else that can be? As you know that 8 plus 1 is 9, 8 plus 2 is 10, not you need 0 there. 8 plus 4 is 12. So definitely you have, what you have here is 4, and you will get a carry forward here of 1. Okay, so 8 plus 4 is 12. That comes here 1. Now you have 2 digits here. Okay, what could those 2 digits be? That would be our answer. So if you are adding 3 plus 1, 4, in all ways you would have to add that. So 4 plus what gives you in 2 digits? So 4 plus 5 give you 9. Not our answer. We need something that would have 2 digits, right, and would have 1 at tens. So 4 plus 5, not our answer. 4 plus 6, yes, can be our answer. That would give you 10 here. 4 plus 7, yes, that would also be our answer, can be the answer. And 4 plus 8 would be the answer as well, can be the answer as well. 4 plus 9, how about that? Yes. So there are 4 possibilities that are building up. We can't go further because you have just 1 digit number that you need to figure out. So what essentially building up here is 34 plus either 68. Similarly, replace 6 with all these numbers. So there would be 4 possibilities that we would end up getting answers like this. So option number C. Let's move on to the next question. Here are 4 sentences and their translations into Mandarin and invented language. The 2 lists are not in the same order, English and Mandarin, okay? It's not in the order. So what the next statement says, how should we translate the sentence, Mom loves oranges? Okay, let's look into it. So we have in English, Mom likes apples, Dad likes oranges, brother loves apples, sister loves apples. Okay. And if you look at the Mandarin sentences, ato bem kito, autum kete, eke bem kete, aluk tum kete. So what we need to pay attention here is how many times a number has been repeated, and if the same number of times that sentence or the word has been repeated here would be equivalent to the English word meaning, right? So we have 3 repetitions of apples here, right? And if you look at here, there are 3 repetitions of kete. So what it's building here is apples is equal to kete, okay? And that would make it obvious that oranges is equal to keto. Remember that? When we look at the question that they're asking, Mom loves oranges. So we need to ensure that where the option would be correct would have and must have keto. Okay, so that means our option could be either this or this or this. We need to rule out option number A and D because both of these do not include keto. Next, now we need to figure out what would mean by mom, right? So look at here, we have likes and loves, right? That means that there are 2 occurrences of likes and 2 occurrences of love. We won't be able to figure out which one would be what, but let's look into it. So with keto, which is orange, you know, is bem, right? So Dad likes oranges, so like is equal to bem, right? So that means that definitely love would be tum, correct? So when we say Mom loves oranges, we need to figure out the option which would have tum. That means option number C is making more sense, because you have love, which is being represented by Tom, not Bem. Okay, so it looks like option number C is going to be our answer for question number 21. So let's get into question number 22. The biscuit section is a cookbook. In a cookbook has 6 pages. The sum of all the page numbers in the section is 147. What is the number of the last page in the section of the book? So what we would do is first to find out the average number to get closer to the range. So there are total 147 sum of all the page numbers, and there are 6. So if we divide 147 by 6, so we would get the average of 24, and would have remainder as 3. So what we find out here, that if we have a book in a sequence, probably 24 would be a number somewhere in between, and if we have some number as 25, then probably 23 here. Then if we have a page next to it is 26, maybe 22 here. Why we are doing that is because the average is 24 with 3 remainder. That means that the numbers would be somewhere 24 for all the 6 numbers with extra 3, right? So when we do 24 and when we do 25, it's definitely plus 1, which is plus 1 of 24. Then we need to go back in minus 1, so we can nullify, we can neutralize what we are adding, and then we do the similar subtraction there to nullify that. Then we move further down to 26, which is plus 2. Then we go back to minus 2. So that would give us a sequence of 5. However, there is one more that you would be wondering whether to go back or add further. Since we have 3 more left after 24 times 6, then we have here 24 times 6. Basically, then we must go further down to 27, which would be plus 3 of 24. So that would be what it looks like. The question they are asking is, what is the number of the last page in the section of the book would be? Then answer would be 27, option number B. Next question we have is 23. 6 white cubes are joined together as shown. The model is then painted blue all over. When the model is pulled apart, how many faces of these cubes are still white? So we need to look at the number of joints basically to get the those numbers, and when the cubes would be pulled apart, those number of joints would still be there intact, right? So if you look at this, there is this joint 1, then another is 2 here, definitely 3, then we have 4 and 5, and we need to multiply it to 2, because one if belongs to this side, another belongs to this side, so it would be mutual. One is here, another is here, so we need to double that. So there are 5 joints, 5 belonging to 2, because those are clubbed together by the 2 cubes, so we will need to multiply it times 2, but that would be 10. So option number D. So thank you for watching until question number 23. I will come back with further questions in our next video. Until then, take care.